Hello and welcome again to Doz's Television Workshop, where today it's part 3 of repairing Matt's Gibson G101 combi organ. Couple of apologies, my voice isn't up to its usual standard because I'm just recovering from a rotten stinking cold, most importantly not COVID. So yeah, I'm not feeling best. And the other thing is there's some background noise from a fan. That's because we're trying to heat the workshop a little bit on account of, unlike last time we were working on this, when we had balmy 18 degree C temperatures here in the UK, which was a bit unexpected for the end of November. The night before last, for example, now, it went down to -11 on the temperature gauge outside. So yeah, it's a bit chilly. And now my garden looks like this. Anyway, enough of that. Let's get into the repair. Right, we've got the organ back on the bench. I've actually got the keyboard supported up on some old video cassette cases here. I keep a stack of them around for when I'm doing vintage video recorders mainly, but they're very useful for sort of propping things up. And this is so the keyboard is operating properly. Now, unfortunately, now when we switch on, well, you can hear that, but there's a definite mains hum, which isn't correct. I do think we've made an improvement with the keying though. I did initially think all my troubles actually with the hum were down to this faulty adapter that was plugging into the output jack here on the chassis, but it's got absolutely nothing to do with that. This is faulty, and in fact it's going over there in the bin. So yeah, I'm not quite sure whether we've managed to introduce another fault into the power supply, because we were working on that last time. So I think we need to check that, or maybe we've got some wiring harness issues within the unit itself. So let's investigate that. Okay, so I've got the power supply back on the bench, and yeah, let's switch it on and see what happens. So our nasty hum is still there, and I've noticed as well, after just a few seconds of operation, this transformer's getting hot. Something is drawing a lot of current, so I'm wondering whether we've got a diode failure. That would give us the symptoms, or perhaps we've got some other problem. But I've also noticed, if you look here on the ammeter for the power supply, I'm just going to switch the power on. Well, we're pulling half an amp. That's a lot of power. That's wrong. So what I'm going to do, I'm just going to disconnect the organ DC power supply from. So this plug feeds all our power voltage rails into the organ. Switch back on. Let's watch that current again. Obviously we won't get a hum because we're not connected, and we're getting almost nothing. We've got a problem with our organ power supply somewhere along the line. Now I've also noticed that all of a sudden the bass section on the keyboard, the black keys up at the one end that you can't see because I've got it on its side, aren't functioning. So we have developed some sort of short circuit somewhere. And I don't want to run it in this condition. One, because this transformer, I mean, that's warm now, and that's only been on, you know, a few seconds. I'm not going to leave it running in this condition because something is very clearly wrong. What we now need to do is trace this back. The only things we've really disturbed are this wiring and the chassis itself. So I think the next trick is to take the power supply out of the way again, look at the organ and inspect that and see what's happened. Maybe we've pinched a wire in the loom. I don't know, but yeah, let's have a look at that. Okay, so I've sort of inspected around the place and I can't see anything blindingly obvious. I think our base not operating may be a red herring, because there's a base level pot on the front and that may be turned down. So I think the sensible thing to do is over here we've got the power supply plug. I've got my one side of my meter connected to the grounds there. I've got my meter set to ohms. Can you see my meter set to ohms? There you go, overload, open circuit in other words. So I'm just going to meter between here and ground and see if I can see any readings that are unusual. Unusual. That's pin 1, 1.2 meg ohm near enough, so that's not going to be loading our power supply down. Number 2, 35k. I wouldn't have said that's insignificant. Number 3, open. Number 3 is indeed not connected. Number 4, nice thick wire. This would do it. Number 4, no, 700 ohms. That's acceptable, I'd have thought. Number 5, again, that's 800k nearly. Number 6, 200-ish k. That's again, it's not going to provide a load. Number 7 is not connected. This is number 8. Number 8, 0.9 ohms. Finally, number 9. Which is meggy. So number 8, 0.9 ohms. It's a green wire, a little slender green chap. So unless that is an extra ground, we need to go and have a look at the schematic. So I've called that up here. So this is the outputs that are on that plug. So pin 1 is 100 volts. Pin 2 is our plus 22 volt. Pin 4 is plus 20. Pin 6 plus 16. There we go. Pin 8 minus 22 volts. Certainly, and that is also going to load down the minus 10, look, and the minus 5. They're going to be almost nothing. So no wonder our transformer's getting warm, because we're pulling a lot of current out of the minus 22 volt rail. So yeah, that's interesting. So we have a short somewhere on the minus 22 volt rail. So let's find out what that feeds. So looking on the diagram, we've got 16 volts into our tone generators. 16 volts there. Where does our minus 22 go? 16 into the vibrato, 16 into the master oscillator. It's what you'd sort of expect for the oscillators, because they're driven from the regulator side of life. So it wouldn't drift as the voltage varies. So I can't see minus 22 volts here anyway. Shout if you do. So this is probably why our base isn't working. So this is our collector amplifier. Oh, there you go, 8 foot and 4 foot base collector preamplifier. Well, that uses minus 10, so that's going to be stuck high. Excuse me. Minus 22. So it's on our tab switch. Oh, it's all over the tab switch. Minus 22. All over our tab switch, which is right back at the front of the organ. See where else? Grounds. 16 volts, minus 10 there. Can't see where else it's used. So minus 10 volts again with a collector amplifier there. So it would appear that something has failed short on the tab switching arrangements. So tab switch, drawing 3. Vibrator. No, none of this is going to minus 22. Four-foot groups. No. Minus 22 is there again on the glide switch. Interesting, we've got 1 microfarad in there. I wonder if that's all right. Okay, I think it's time to look at that. Okay, so I've got the hinge, the switch panel hinged back here. Ignore this clip lead. That's just attached actually to a bit of weight there, just so it holds it back in position. Now, I mentioned before that our green wire, it sort of comes round the side here, makes its way up to the switch panel here. So if I measure between that wire and ground again, we can see that's horrible. I've also noticed actually that this grey wire here has been poorly soldered in the past, and it goes onto this binding post here, I believe, but I am going to confirm that on the schematic before I resolder it. In fact, looking there, you can't see because this is going to be, I'm facing backwards, so I keep putting my head in the way, I suspect. You can actually see a little bit of insulation on there, so I'm pretty convinced, but I will just check. So that's unpleasantly short circuit to chassis. That's our minus 22 volts. You see it's down to ground. So I think the first thing to do is just, there are 1, 2, appear to be 3 wires on there. Just seeing where that goes to. It's not helping because obviously this is also beeping when it gets to ground. It also seems to go to this wire here, again green, wraps round there, goes over to, oh, it goes all the way over to here, I think. Yeah, indeed it does. So we've got a short all the way across there. Now if I had a milliohm meter, we might be able to see a difference there. I don't have one. Must make one day. But as it is, let's just drop that wire off there and see if that removes our short. There are 2 or 3 on this binding post here. Let's just refresh that with a bit of solder. You can see that. Not quite got the right angle. Let's just angle that camera up a bit. You going to stay? Probably. So let's just refresh this bit of solder on there. What I'm hoping to do is isolate it from the plug really, so I can check that this bit of loom is intact. Or maybe the fault exists on our switch panel itself. So we did of course replace this capacitor, but I don't think that's part of the problem. Okay, so that's just lifted one of those wires. Let's just see what that's had an effect. Yes, it has. So that is short circuit. Right, where do you go, my lovely? Really want to try and see where it's going and where it's short, because it is very short. It's nothing to do with that, is it? No. Okay, right. It does indeed go back into this loom here, which ends up over here. So now we know the base circuit is down, but is this just a misnomer? So is it any of these green wires on here? No. Okay. So, in fact, if we're clever about this, if this measures short, it is this one, isn't it? And pin 8. No. Okay, let's go between that wire and pin 8. So if I take this off our ground connection, put that onto this end. So this is our negative side of our meter. It's not the plug. Okay, so that's not it. Despite the fact we've isolated the fault, it's still present. I'm just going to hook the ground side of the meter back up to these ground connections that live on the power supply. Just check that's short again. Yes, it is. Right, okay. So we've got a fault in there. Now, where is that going? So it is this wire here. I'll just hook on it. Yep, I can. It's that one there. Where is it going? It's in this piece of loom here. So this one could be either, couldn't it? I think the best thing to do here is just to snip these off. Let me snip that one there, look. And pull him out. Okay, so it's in there. Where are you beeping? Ah, hitting the chassis. It's that one there, which is it's like a darker green, is that it? Let's just see if we can get a bit of movement on it and then we'll just confirm it's the right wire. No, it appears not. Okay, so what other greens have we got? I don't think it's that one. Is it this one? Nope, it's not that one. Look, that goes through there. We may have to remove another little bit of lacing cord there. Okay. Where are you? Oh, okay. It's this wire here. Goes into here. Goes from there, goes down there. Where does it go from there? So it's that one there. Let's just bring in the hand camera. So excuse the wobbly footage. There is our errant lead that is, let's just change hands so we get this somewhere steady. So there is our errant lead that's short circuit somewhere. Okay, that then moves along here, sort of intertwined with that blue wire by my finger there. Goes along here, over here, and disappears off down there. So, where are you going? Where are you going? Believably, I don't appear to have enough light. Let's put some light on the camera. There's me a little torch something going on. It is going right down. Oh no, it's going to this, the output panel. So, is that it? Right. So, if it... That's not it, surely. That resistor. It's touching the ground there, look. On the panel itself. Ah. Oh, when we took it out, we must have flattened it. Look at that. No insulation on it from when it was new. Is that our stupid fault? Oh, I'll just get in there and move that out of the way. So I've got a bit of space there now. Look at all these other leads here. Nicely shielded. And this one's ground anyway. And that one isn't. Oh, is that just it? So obviously when we've moved this panel, that got bent across. What a silly bit of design. Right, let's just prove that out. I'm just going to put handy camera down for a second. Right, so we've now got this lead should no longer be attached to ground. Would you look at that? It isn't. We're still on ground. No, that's now open. So if I just beep between there and there, I'm just going to attach it to that resistor. Have we got that on camera anywhere? We have up there, look. That's okay. So if I just attach that, that should now be short. Would you believe it? So what I'm going to do is I'm going to put a bit of sleeving on there so that doesn't happen again. Right. Okay, so I've popped a bit of heat shrink over that resistor, and I've actually routed it out of the other side. It's not the most sensible of arrangements down here, but there we go. That can't happen again. Yeah, I've got my probe connected back to the grounds on the plug there. You can see that? Yeah. So we now, on this green wire, which I've reattached, we should now have, wow, that's open circuit now. So that's encouraging, I think. Just check I've got that good. Yep. Let me just check here. So of course, depending on the position of switches, as to be whether the thing will be loaded down or not, I presume. It's, let me go to proper ohms. Yeah, there we go. 250 odd K. So that's good. That grey wire that popped off this panel here, I can't see that side. Let's bring in handy cam again. That grey wire that popped off just there, that is the binding post to which it rests, I believe. I've had a look in the schematics. We've put that back. Let's turn it all round. I'm going to power it back up with the power supply, see if that hum's gone, and more importantly, see what the status of the keys are. Excellent. Right, I've got everything around the right way again, so I've got the mystical black and white bit facing me. Let's switch the power supply on. Neon is flashing. There is no hum. I can't even see if our ammeter has moved, so it's not pulling much in the way of current. So is our bass back? Yes, the bass is back. Good. This is working. Brilliant. What's our sustaining like? Perfect. So the two keys we didn't have working previously with this one. Okay, let's put sustain on. Perfect. This one. You can hear that one, still not got the right level of sustain. So this D is now doing nothing. So we can remove our blob of blue tack from this key, because that one is now working. We'll move it to that one because it's doing nothing. Everything else appears to be working. So we've got the sustain on this key to sort, and the fact that this one is now doing nothing. So that's D. Okay, this is good. We're almost there. So I've got two keys, one doing nothing. Well, that's going to be straightforward because that was working before. And this one, which is still not sustaining correctly. The faults are finally narrowing down. Well, this key that was formerly working and then wasn't turned out to be a really easy fix. It was, let me explain how the key works. So there are two contacts and the key wire in the middle. Now the physical key moves the wire in between these two contacts. So it sort of moves down to sound the note and then off when it's relaxed to instigate the sustain. Now here's the thing, this one key here, can we see that? Yeah. The one that isn't sustaining properly Put long sustain on. There is some sustain there over none. However, I've got sustains all off. Excuse me. So, correctly working key. You can see that was really sharp. This one, however, if I push it down to activate it and then don't let it up all the way to hit the sustain, it does sustain, look. But if I let it up all the way, so if I do the same with this key, it's never a long sustain. So I think this key switch is working correctly. I think we've got a problem, possibly back to those sustain modules under the back there. So we can have a look at that. But being as there is some sustain, just not the right amount, nothing like long enough, I am just going to check that sort of off contact. Now you see, I am just going to check it is activating, because, you know, if we add sustain in, it's not making that much difference, and I'd expect it to. So I think those are the first things to check. Just the keyboard switch is in fact working correctly. Then I'm going to check our work on that back panel again, counting up from this key, 2, 3, 4, 5, 6, etc., back to this note. Just check that sustain is correct and work forward there. We may have a diode that's not correctly routing our sustain signal through. Could not be being routed through here properly as well. There's quite a lot to think about there. So let's do that. Okay, so my multimeter is just connected here, and that is connected to the wire that goes against the bushing up here. Can't quite get on it. So if I push the key down, it should connect to this front bar here. So we can test that. Yep, that's working. And if it's up in the relaxed position, it should be connecting to this one here. So as suspected, our key switch is working perfectly. These aren't connected, these are separate, here and here. So that's good. We know our key is working correctly. So what have we got? It's this diode here, isn't it? And then off into the guts. So let me just, so the diode is at least working one way. Let's just check it both ways. Might help if I put it on diode check. Which key is it? It's that one. Put the diode on there. Yeah, 0.6 of a volt. Other way, it's open. So that diode is working. We've also got 2.2k in there. Go back around to ohms. Let's just make sure this isn't 2.4. What have we got next to it? 2.6. Yeah, they're within tolerance, aren't they? So that's okay. So our keyboard bit is in fact working fine. Let's check all these wires are in the right position. This one's very nasty, but does work fine. So yeah, they're all in position. That's what happened with that other key, just the wire had slipped off the bushing at the end. So let's just, whilst we've got it in this position, we can get at the sustain circuit. Let's just check which one it is. So it's number 21. So let's just check in here. 21. So it's this one here. And I can't see any errant soldering there. So we'll look at the other side. And progress in our search for the missing sustain. Okay, so I'm just looking around. I put a blob of blue tack on our defective channel here, and if I go one this way, just put a meter on this diode. Can you see that up there? Oh, I can't rest it there. Can you see that on top? You can't. Let's put it there gently. No, you ain't going to be able to see that either. Anyway, I will read out the meter readings to you. So on this orange wire here, I've currently got minus 5.6 volts. If I push the key, plus 4.5. Let go of it, and it's phased to 0, and then slowly swings back negative. Okay, if I go on our faulty key, again, same wire, same diode, plus 4.6. And then very quickly goes back to minus 5. It's like one of our capacitors is not connected. So I think the next thing to do is actually check that those capacitors are working properly. Right, so that's going to involve sort of shifting things around again. Bear with me. Right, okay, I've found something. There is a set of switching diodes for each sustain on this board, two of something and something A, which you've seen us look at before. Now I've measured all of those, but I was just looking in one direction. If I'd have used the component test, the DCA or whatever, I'd have found this. So sure enough, one of those diodes was leaky. So it measured great in one direction, 0.6, 0.7 of a volt. Turn it around the other way, and I still had about 1.2 volts there. So it's leaking like a sieve. So that is bleeding off the charge super quick from our rail and actually causing it to just decay like you do. So I've just tacked one in. Let's have a quick look at the diagram actually while we're thinking about it. So yeah, we can see diodes keyed. Now we are on E4, 21 and 21A. And sure enough, these are the two diodes in question over here. And they form, if we go back up to the actual schematic, you can see where the staccato and sustain are done. There. So these are the two switching diodes. And sure enough, it's equivalent to that one, so it's leaking any charge away super quick. Or is it that one? No, it must be D9, I think. That's leaking all the charge away from our sustain capacitors here. So I'll just strap one in, powering on. Let me lose that. We find the defective key, and okay, they're performing all right at the moment. Switch the sustain on, and here's the duff one. That is a result. I am just going to now, I'm going to go and check every one of those diodes to make sure they're actually working okay. Just in case one is on the cusp, shall we say. I don't want to see this thing again really, so I'm just going to go through the whole lot and go through them. You don't want to see me do that. It's mind-blowingly tedious. Incidentally, the diode appears to be nothing more than a small signal diode, so I've used a 1N4148 in there, which appears to be performing perfectly. Right, I'm going to go through and manually check every one of these on both long sustain and short, just to make sure that we've got it all matched up and working. Right. Okay, so we've got the diode switcher matrix now seems to be working. We have one problem remaining, and it's quite a simple one to solve once the chassis is back in keys. Look, all the keys are working. There is some issue with pickup occasionally when you move the loom around, but of course once it's back in its case it'll all be dressed correctly, and yeah, we shouldn't have any more problems. There's only one problem, and it's this key here. As you can see, it is sustaining for too long, but it is simply an adjustment of this, because if I do this, you can see it sustains properly. So it's not making that closed connection properly. And what I'm going to do is, once this is all bolted down and rigid in the case again, either that problem will go away, or we can actually adjust it in situ, because on the bottom of the case there is a cover here that we can lower down, and I can scrabble around on my back and just adjust either that contact or this bushing. So I think we're good to go. A couple of other things that Matt wanted. He wants it working on 240 volts. That's still giving me a bit of a headache because there's physically not enough room in the case. And he wants a jack socket on the back of it. Jack socket on the backs. That's going to be a job for our 3D printer. I've ordered some new 1/4 inch jack sockets, will be here very soon. So yeah, let's get this back in the case and start working towards a 240 volt supply. Did I say 110 before? It is 110. He wants it 240, 220. So that's fine. We may end up with an external auto transformer to do that. Far from ideal, but given the space confinements we've got within the instrument itself, I think that's how we're going to have to do it. There we are, the Gibson G101. Let's get it back in the case and work on from there. I just want to show you this little mod I've done to the input panel before we replace the chassis. This yellow wire here actually links out, so you don't have to have the pedal board plugged in, which we don't have. But I've added in this yellow wire link here. This output jack, normal 1/4 inch output jack, it's actually a stereo jack. So you can see we've got ground at the bottom, and then we've got the tip and the ring. So the reason is that when you plug in the matching Gibson amplifier, the reverb tank in the amplifier comes up on the ring and then is fed back to the reverb switch in the organ itself, and then appears on the output. Now Matt wants an external output jack fitted to the rear of the unit, so we've tacked that in there, but I have shorted out the reverb tank, because obviously if you put a mono jack in there, it's no problem, it's shorted out anyway. But with the external jack, because it's a mono jack anyway, that's not going to be shorted, so we run the risk of picking up noise here. So I've just shorted that to ground with that yellow link. Yeah, right, let's get the chassis back in. So after being on the struggle bus for a few minutes, we've managed to get the power supply back in, but look, one of the wires has come out of the octal socket there. We're going to have to repair that in situ. What a pain. Okay, so we've got to replace the missing sort of dampening foam that's under here. These two are intact okay. This is okay in one direction, and the base switches haven't got any at all. And I've been looking around for some suitable material, and I found this stuff. It's foam. It's self-adhesive, and it's the sort of thing used for sealing round windows and doors. A sort of draft excluder strip, and it's exactly the right size. So I'm going to use a bit of this stuff. I need to cut that off there. Cut it to the right length, and it'll be absolutely perfection, I'm thinking. Well, I just cut the right piece. Yes, I have. Why is it stuck to itself? Oh, I see what's going on. Okay. Right, so, yeah, we need to cut this to about the right length. About there. Peel the self-adhesive strip off and just stick that back in place. Hey, look at that. That didn't take long, did it? You know what I'm like with sticky back stuff. So we're just going to pop that in place. Absolutely perfect. Yeah, that works really nicely. That's quite something. Right, we need another bit for under there. Oh no, my bad. That's actually still in place. So, yep, it's just the base switches. So great. And just if you're wondering what it is, it's this stuff. 151 adhesives, foam weather strip, windproof, weatherproof, waterproof, self-adhesive, stop drafts, ideal for windows, doors, and Gibson G101 organs. Epic. So there we are. Matt's organ is all back together. Remember the key down the bottom that wasn't quite, the sustain wasn't triggering properly? By the time we put that back in the case and it wasn't sort of flopping around like it was on the bench, that key was working perfectly. So that's great. So it's done. Or is it? Well, no. Matt always wanted a UK or European 230 volt power supply for it. And he's not keen on the idea of a separate 230 to 115 volt transformer being on all the time. I can sort of understand that. And we had run out of options. We tried to buy one that turned out to be the same as the one we had, which incidentally I put back on eBay, and somebody else has made use of that. In fact, it's gone back home to the States. Dread to think what the shipping's going to cost them, but anyway, they're happy with that. So yeah, good. Now, the conversation then occurred. Now, I used to work for a company in Tewkesbury, and they had a coil winding department. So they used to obviously have coil winding machines, and those machines were supplied by a company. So I rang that company and I said, now, I think you sell coil winding machines. I know you sell coil winding machines. Could you provide me the name of one of your customers that could possibly wind me a bespoke transformer? And I said, years and years ago, we used to use JJ transformers in Cheltenham. They disappeared when I stopped having transformers wound, I suppose. Anyway, I couldn't find much trace of them on the web anymore. So a couple of other companies I'd rang with no luck, really. Anyway, so I rang this company. He gave me the number. He said, well, JJ Transformers does in fact still exist. They're now known as Coil Tech. So I've spoken to Julian at Coil Tech. So hopefully he's going to be able to make us a bespoke transformer. Now, it won't be the sort of EI sort of square transformer. Let me look for an example quickly in the workshop. You know the sort of thing we mean. Something like that sort of transformer. This one is for a forthcoming project that you will see very soon on this channel, I hope. So it's not going to be the sort of transformer that's fitted in there at the moment. It's going to be a toroid, but that brings us some benefits. There's a lower magnetic field, and yeah, it should be a lower noise thing all round. So that's fabulous news. The bad news is bespoke things, they take a while to come. They take a while to make. So Julian thinks about 8 weeks, but he still hasn't got the details. He's obviously closed now for Christmas, as it is here at the moment in the UK. So yeah, that's going to be a little while coming. So we will come back to Matt's organ, and we will look at fitting that different type of transformer into the power supply. And hopefully Matt can have it back. Anyway, thank you for watching this part 3 and sort of semi-final part of Matt Berry's big organ, and we'll come back to it in about 8 weeks. Thanks for watching. Click like, subscribe, do all that, cobblers, and I hope to see you back very soon here on Doz's Television Workshop. Cheers now. Perfect, one bloody take. Amazing.